So good afternoon, everyone, and welcome to another Outstanding Authors at Google Talk. Today we have the distinct privilege of hosting Michael Hanlon to our podium today. He's a preeminent science writer, currently serving as the science editor for the Daily Mail over in the United Kingdom. And he's the author of such super cool books as The Science Behind the Hitchhiker's Guide to the Galaxy and The Real Mars. Today he'll be speaking from his most recent book, which is 10 Questions That Science Can't Answer. And we also have copies of his penultimate most recent book, The Eternity, if you want to take a perusal later on. As Googlers, we always have our eyes on the future, and Michael helps us understand the state of the art and the state of the future. So after the talk, we'll have time for some brief Q&A, and please feel free to use the mic to improve our recording for YouTube. Without further ado, please join me in welcoming Michael. Thank you.
Good morning, everybody. Thank you for having me. Thank you for coming.
Thanks for using WebEx. Visit our website at www.webex.com.
Go ahead and ignore that. I'll go ahead and ignore that. I found it amusing. I found it so hard to find this building today, irony and so forth. Yes, thank you for having me. As Cliff said, I'm a science writer. I'm not a scientist, which is a big difference. People often get them confused, or you probably won't be confused after you've heard me wittering on for a few minutes. A couple of years ago, 3 years ago now, my publisher came to me and she said it would be very good if you could write a book about mysteries, because not being a scientist is often a good perspective to look at the big field, look at the big questions that kind of fall between the gaps from the very profound to the very ridiculous. And I said, well, how many? And she said, well, I don't know, how many have you got? So I thought, well, I started thinking, and I thought, well, there's about 26 big ones, time, consciousness, the usual ones, and some less usual ones as well. And she said, well, it should really be like your principles, here are my principles, here are 10 of them, and if you don't like them, here are 10 more. So only a very foolish author writes himself out of a sequel, so I just picked 10. I wanted to look at some of the really great mysteries, the things which science seems to be incapable of really addressing properly. And there's a great quote from G.K. Chesterton, the poet only asks to get his head into the heavens. It is the logician, or the scientist, or whoever, who seeks to get the heavens into his head, and it is his head that splits. I think that's very true. The more you think about some of these things, the more your head does start to hurt. It's pretty clear over the last 100 years that science alone has all the interesting questions, but happily not all the answers. There is still great mystery here, and as we shall see, this is not the case. 100 years ago, people thought that science was just about to get it all sewn up, and then along came all sorts of troublesome characters like Einstein and the quantum physicists and so on. Why isn't this working? Brigitte Bardot is not supposed to be there, nor is that fat person. It's good to see the Google computers working so well. One big, great mystery, fishy things about the universe, for example. I'm not going to run through the chapters one by one, because that would be dull and predictable. I'm just going to skittle around the book. The fact the universe exists, if you want to upset a cosmologist, you sort of ask them why it's there at all. It's very fishy indeed. Why did the universe go to the bother of existing, when clearly not existing would have been far easier? Another very strange thing about the universe is it's conscious. We know that's so. I know it's so. I know at least one little bit of it is conscious, me. This is quite staggeringly strange. Most things are not self-aware, but we here on Earth are. Probably we share the Earth with several billion animals. Most of them probably are self-aware too. This is very, very odd. Now, these are sort of big, profound questions. And also I've got a chapter in my book which is maybe a slightly less profound question, which is why are people so fat? Now, this is a photograph I took last week in my country. We've been having some very warm weather on the beach. And this is more or less a typical person now in my country. This is the fattest person actually I could find in Britain last week. This person was sitting next to me on the plane from Seattle the other day. So maybe this is typical of the North American continent. And a couple of weeks ago I went to France and I took a picture of this person. And she was actually the fattest person I could find in France. So there are some differences which transcend class and wealth and are slightly mysterious. And in fact, there is a doctor working over in Maryland who thinks there are some very odd things about the obesity epidemic that we've seen, which has really taken off since 1980. Odd things include the fact that calorie input into people like Americans, British people who are getting fatter and fatter has actually gone down since then, and the amount of calories burnt off in exercise has actually gone up, and yet we keep getting fatter. What's the cause? Is it something weird that we're doing, like eating high fructose corn syrup? That's been labeled as one thing. Some people have suggested a virus. This doctor in Maryland is suggesting there might be a viral component to obesity. People laughed at him, and then they all remembered the case of the stomach ulcers, which of course everyone knew was caused by stress, until somebody won a Nobel Prize for proving otherwise, swallowed some bacteria and got a stomach ulcer as a result. Another question I look at in the book concerns the sentience of animals. Again, it's very interesting from a sort of science history perspective. For several centuries, several millennia really, science and the popular view of animal sentience were at loggerheads. We tend to think of the old-style world as being very cruel, very heartless, nature red in tooth and claw, and the Middle Ages as being very brutal. But actually, people are very surprised to hear that in medieval Europe, for example, animals were considered sentient. This was considered to be the default explanation for their behavior. In fact, in several countries, in Switzerland in 1316, a pig was put on trial for murder, and I think it was acquitted. In Hamburg in the 15th century, some rats were put on trial for causing the plague, and actually they were guilty, but they had some very good lawyers, being rats, and they got off too. So the idea in the 16th century that an animal was sentient, had rights and responsibilities, and could act as an independent, sentient, conscious agent was not seen as being at all surprising. And of course, now we kind of think the same thing, but there was a gap between about the sort of end of the 17th century and the middle of the 20th century, when the ideas first promulgated by this man. This is, who's this? You're all Google, you should all know who this is. Anybody? Nobody knows who this is. This is René Descartes. He's one of the most famous people in history. He was a French philosopher, and he famously taught that animals were automata. He used to do things like put red hot pokers up their bottoms and write about their responses, saying, you know, I'm not being cruel. This is just the response of a machine, effectively, to what looks like pain, but there's no actual pain being going on. And strangely, this was an idea that took hold in science. This was seen as the standard Enlightenment view of animal sentience. There wasn't any. And right into the 20th century, we had men like B.F. Skinner, who's actually too boring to show a photograph of. He was the arch behaviorist, and he put pigeons in boxes and rats and taught them how to peck at things in a certain order. And he said, basically, the brain was just a box. You had stimulus in and responses out, and he actually tried to bring his daughter up in a Skinner box until she was taken away by child welfare. Actually, that didn't happen. This is a photograph of a sentient being. This is my late dog, who was called Twiglet. She died about 3 years ago, and I'm pretty sure she was sentient. She certainly did funny things like hiding socks, and she would be able to do things like recognize certain makes and models of car. Of course, she could have been a completely zombie. She could have been just a machine, behaving as though she was sentient and intelligent. But I tend to use the principle of ducks. If it walks, quacks, and swims and flies like a duck, it probably is a duck. And now we're quite happy to accept the creatures like this. This person was sitting the other side of me on the plane from Seattle. And even creatures like this are sentient. And in fact, just a couple of weeks ago, there was a fascinating experiment done with this chap. This is a slime mold, and they gave it a maze to find. They put it, whatever slime molds eat, I don't know what slime molds eat, something even worse than slime molds, I suppose, at one end of the maze, and the slime mold was actually able to find its way through this maze faster than a rat, and no one has any idea how. It was even faster than the CEO of most hedge funds. Another question from slime molds to time. If I knew what time was, I knew what I was supposed to say next, I would have a Nobel Prize. What is time? No one knows. I think 3 awkward facts about time. No one knows what it is, why it is, or if it is even there at all. I'm sure, being smart, you've all read lots of ideas of block time versus flowing time, Einstein's view of time, the past, present, and future all being equivalent, and people like Arthur Eddington viewing that time is like a river. Why do we remember the past and not the future? Why is the past set in stone and the future's up for grabs? I think one of the nicest little explanations of why time is weird came from a poet, Austin Dobson, who wrote, "Time goes, you say, ah no, alas time stays, we go, or else were this not so, what need to chain the hours, for youth were always ours. Time goes, you say, ah no." And I think this is nice because it kind of suggests that the way we view time, the way we view that time is flowing through us may be wrong. It may be us that's flowing through time. And increasingly, a lot of psychologists you speak to, there's stuff about this in my book, think that our perception of time, psychological time, is probably something quite distinct from physics time. And I think because we use the same word for the two things, we may be being confused. Nothing in known physics corresponds to the passage of time. Most physical properties, like space, for example, you can go up and down, you can go backwards and sideways and forwards, and they're all reversible. Time doesn't work like that. It goes from states of low to high entropy. Nothing else works quite like that. Another question, I'm rattling through these. Can I live forever, please? There's lots of people in this particular part of the world who make a lot of money persuading shareholders to buy stocks in their companies, producing sort of gene therapy, immortality pills, and so on. So far, sadly, none of this has worked. This person who we'd all like to emulate, this was, does anyone know who this is? Oh, this is Jeanne Calment. She is the world record holder to date for longevity. She died in Arles in France in August 1997 at the age of 122 years and 314 days. Very cross that she missed her 123rd birthday. Now, lots of people out there think that in a few years, a few decades, we're all going to be living this long. She was actually very fit and healthy towards the end. She gave up cycling when she was 116, and she gave up smoking at 118 on the advice of her doctor, who said it was bad for her. Her response to her doctor is not recorded. She learned to use email before she died, and she knew Vincent van Gogh and was actually propositioned by him as a child. That is an extraordinary life, if you think about it. To have had Vincent van Gogh ask you to go to bed with him while drunk, and to have sent an email. I cannot imagine there's any other human being that has bridged two worlds quite like that. A really nice story about Jeanne Calment is that when she was in her 80s, she did a deal with a family lawyer. Her husband had died, and her lawyer said, "Well, you live in a lovely apartment in Arles, one of these grand old turn of the 18th century French buildings, obviously French, in Arles. I tell you what, I'll give you a lot of money for it, and you can live in it sort of rent-free until you die." This arrangement was still in place when the lawyer's grandson died. So it's a very, very nice way to stick two fingers up to Mr. Death. Why does she live so long? We don't know. Why do these things live so long? This is a sea anemone, among the stupidest of the creatures on Earth, but they have got one thing right: they live a very long time. I spoke with a marine biologist once who said that there's a good chance, they study sea anemones, that they may be effectively immortal. Of course, sea anemones die, they get eaten by fish, and they get knocked off rocks by storms and waves and things. But actually, if you put a sea anemone in a nice tank and you give it its nutrients and its food, and you don't freeze it or put sea anemone eating things in there, they don't seem to age. Their cells don't age, they just keep on replicating as needs must. And there might be somewhere, some little crevice on the Great Barrier Reef, there might well be a 10,000-year-old sea anemone out there. Maybe death is the price we pay for not being sea anemones. So far, this isn't coming up on the screen for some reason. There are several tricks doctors have come up with, scientists have come up with to live a long time. One is to starve. I once spent an entertaining evening with Professor Roy Walford. He was professor at UCLA. He took part in the Biosphere 2 project in the Arizona desert, I think in the 80s. And he came up with a notion, he's a biologist, he came up with a notion of calorific restriction. And he said that he put a load of rats on a very restricted calorie diet, down to about a third of their normal intake, but maintaining the nutrients and the vitamins and so on. And they lived quite a lot longer than rats fed on a regular diet. So he started an experiment on himself. And I went to see him in his house in Venice Beach in LA. And he was about 70, and he was eating 900 kilocalories a day, which really isn't very much. He looked terrible. We had dinner, which was a bowl of rice and a glass of water. And sadly, he died a couple of years later. I don't say that to be nasty and funny, just that it didn't seem to do him any good, and he started a club, an online club, the Calorific Restriction Club, and they sort of devotees of Roy Walford starving themselves to long life, and one suspects it's not going to work. Another one is exercise. As a journalist, we're bombarded with health scares and health stories and health advice, and you have to just write it all and hope it's all true, and of course none of it is really. But one of the things that does seem to be good is exercise, physical exercise. Humans are very good at running. One of the things you're taught as a child is that Homo sapiens was a weak, feeble animal on the African plains. We were capable of being outrun and out-eaten by more or less anything, but that's actually not true. The one thing humans are better at than any other large mammal is running. This is not widely appreciated. Not over short distances, of course, but over long distances, we're better than antelopes, elephants, horses, you name it. And that we have tremendous stamina. And one of the things our bodies seem to be very, very geared up to do is running. And people running a lot is definitely very good for them. And it's very hard to have any sort of concrete evidence on longevity, obviously, with humans, because we live so long anyway. But that seems to be a good thing. Another thing is to choose your parents carefully. Try and find some parents who made 100 if you can. It's excellent, and then time travel comes into that. If you go back and become your own father or mother, you can probably have more say in the matter. Another good way of reducing your chance of dying young is to spend the ages of 17 to 22 in a locked room if you're a male. This is actually a nasty little death spike at this age. Car crashes in the West, violence across a lot of the world. In some societies, particularly some of the troubled societies in South America, for example, single-digit percentages of young men are killed between the ages of 15 and 20 through violent acts. I'm thinking of some of the tribes in Peru and Brazil. And this is a very dangerous time. It's the testosterone surge. Young men become very stupid. Very aggressive, very violent towards each other. It's actually quite a good way of getting mates and getting your DNA out in the world, but it's not so great for longevity. You can worry about telomeres. Lots of people talk about telomeres, I think partly because they like the word. It sounds kind of sexy and sciencey. The only problem with telomeres is that actually in some species the telomeres get longer as they get older, particularly in seagulls, and seagulls don't live forever, and we don't really know why. If you see this word or this term on a bottle of anything, usually it's best to ignore it, especially if you see the word quantum combined with it on the bottle of anything. I was chatting to Roger Highfield, I was reading a letter by Roger Highfield, who I know, who's the editor of New Scientist, a couple of weeks ago, and he was saying how if they put the word quantum on the cover of New Scientist, they sell 16% more copies that week. He didn't really know why, and that led somebody to ask him, well, what word can you put on the cover where you sell less copies per week? And the answer was potato. And they're now going to run an experiment where they put a story about quantum potatoes on the front cover. Another thing you need to live quite a long time is luck, avoiding falling things, avoiding falling objects, avoiding those 17 to 22-year-old men when you're a bit older. By the way, the greatest chance of being killed by a 17 to 22-year-old man is if you are also a 17 to 22-year-old man. The people who have most reason to be frightened of these people, and they really are terrible human beings, most of them, are themselves, which is perhaps a consolation. I thought I'd do a chapter on the stupid, partly because I feel an affinity with them. And he said, going through his notes, trying to find where he is, this isn't really a science question, it's a social science question. As we all know, social science isn't real thinking of any kind, really, but it's a nice little question. I wrote a piece in a British political magazine a few years ago called just this, What Are We Going to Do with the Stupid? And it strikes me that that section of society, which is too bright to be basically dysfunctional, but too stupid to be basically functional, is an important sliver of society that is ignored by politicians, the public, the media, everybody. These are the people who don't fall into the category of being looked after. They're not mentally disabled, and yet increasingly in a more and more knowledge-based society, they fall between the cracks in the paving stones. They're not able to keep up, and the problem is exacerbated by the fact that we strive towards a meritocracy. And a meritocracy is seen to be good. It's better than having a society run by dukes and earls and kings and queens where the people at the top are there through accident of birth. That doesn't seem fair. It doesn't seem fair that the CEOs of companies should be the sons of the last CEOs. That doesn't seem fair. Much fairer, surely, to select through ability and hard work. And this place is probably the shining example of it. I mean, I don't suppose there's anyone seriously who works here who is dumb. The problem with a meritocracy, although it seems very fair, is what happens to the poor people without any merit. We just don't ask this question. What are we going to do with them? The left traditionally pretends they don't exist and says all we need to do is educate them and they can all be Einstein or work at Google or whatever. The right says, well, to hell with them. And these aren't satisfactory solutions because, sorry, just said that. If we have a society where stupid people don't count, where people who, with all the best will in the world, with all the education thrown at them, with all the goodwill and with all the effort made to improve their lot, cannot find a place in society, you end up with problems. You end up with crime, you end up with dissatisfaction, you end up with psychological malaise. And I argue in my book that 100 years ago, although there was much wrong with the world 100 years ago, and I would far rather live now than then, for millions of reasons, we did at least have the idea then that people of all abilities had some merit, and people who weren't able to contribute maybe intellectually, we could find something else for them to do. And particularly in my country, the idea that children who are not academic are worthless is growing. The exams are set up for people to fail, if you think about it. And we think a lot about what we do with the kids who pass these exams. We don't think too much about what we do with the kids who fail these exams, and I think that's a shame. This is a rather big jump to one of the chapters in my book on dark energy and dark matter. Now, this is a photograph I took yesterday of some dark energy. And this is a photograph I took the day before of some dark matter. I'm sure you're all perfectly familiar with these chaps. Very problematic. I was in Geneva a few weeks ago, looking at them trying to turn the LHC on for about the 9th time. I think the last time it was screwed up, some pigeon dropped a baguette into one of the transformers, and they had to turn it off because they were worried about it exploding. And of course, this is the time travelers from the future screwing things up so that we don't muck around too much with causality. And when I asked this of them, they just gave a thin smile. We don't know what dark matter and dark energy are. One of the nicest numbers in science is 10 to the power of 120, which is the observed and calculated discrepancy between the main parameters of dark energy, what you see and what there should be there. And that is quite a large number. As I'm sure you know, it's even bigger than Google. It's, quintillion Googles. And that's a big discrepancy. So we're on the case, but we're not there yet. I have a big chapter on ET. Not just, where are the aliens, but more fundamental than that, really. What is life? Is the universe alive? I'm sure you all know this is the 50th anniversary of SETI, the search for extraterrestrial intelligence. And not a million miles from here, there is an outfit called SETI Institute, which is working on this. They would consider to be astrobiologists. NASA has an astrobiology institute now, which a cynic would say is the study of things which do not exist. To which an astrobiologist I know said, well, what about history? That's the study of things which did not happen by people who were not there. The great thing about academics is they are often so mature. So one way to find intelligence, aliens, if they're out there, is to use machines like this. This is the Arecibo radio dish in Puerto Rico. It's a rather a spectacular thing, actually. It's built in the natural bowl in the mountains. And the SETI Institute borrows time on this when it was publicly funded, partially by NASA, until the 1980s. It used to get more time. We don't actually know whether the world, as in the universe, looks like this place on average or whether it looks more like this place on average. I took this photograph around 3 weeks ago. Could anybody tell me where I'm standing? Okay, I was standing on Pluto. You should be able to tell because that is, of course, Pluto's moon, Charon, over there, and the very small sun over there is the dead giveaway. This is not a photograph of Pluto. This is an artist's rendition of Pluto, because, of course, no one's actually been there. Pluto is maybe typical of objects in the universe, small, icy spheres a long way away from their parent stars. There may be more of these than there are grains of sand on all the beaches of Earth. We don't know if the universe is like this. This is the Star Wars Cantina, a rather poor rendition of it because I couldn't get a copyright-free version of the original one. This is a photograph taken on Gliese 581d, which is an exoplanet discovered a few years ago, which last year or the year before last was calculated to have an orbit around its star, which put it in the so-called habitable zone, which is the zone at which liquid water should be able to exist on its surface. That isn't a star with a hole in it. That's actually Gliese 581c partially eclipsing the parent star. And we don't know if this is just a ball of rock like Pluto with some ice on it, or indeed some water, and whether there are rather nice creatures like this on the surface. This is a still taken from a small Canadian art house movie, which was released a few weeks ago. I don't know if it's come to the US yet. It's actually got some quite nice special effects, so I would advise you to go and see it. I've forgotten the name, but as you can see, this planet has some rather nice, rather cool scenery, floating islands, which I'm told were modelled on the scenery you see around Cape Flattery on the Washington State coast. Rather surprising that there are actually fewer than 20 tenured scientists in the world at the moment working on the question of the origin of life here on Earth. Forget space, we don't even know how life began on Earth, and I think we have to really sort this one out before we stand much hope of finding out whether there's life elsewhere. And I've certainly got the word 42 on my screen, which shouldn't be there, but never mind. We should try and find out why it's there. Chapter in my book, I'm told here, on life, the universe, and everything. What is reality, really? Philosophers and college students have been arguing about this with their coffee late at night for years and decades and centuries. No one's really come up with an answer. The only person who's had a go was Douglas Adams, of course, who said the answer was 42. And according to a mutual friend, he just thought of this while sitting in his garden drinking tea, and he just thought the number 42 sounded cool, and it didn't have a 7 in it, which all kind of portentous numbers normally do. But what's amazing is the Douglas Adams fan club have been looking for examples of 42 in nature ever since. It was just a random number, but the idea that you might be able to boil down the deep secret of the universe to one number is very, 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 very nice. This is a picture of the universe yesterday. This is what it looks like. This is the Hubble Deep Field, which is majestic if you think each one of these galaxies is around 100,000 light years across, and 100,000 light years is quite a long way, even not in traffic. And the universe that we see now is 7 orders of magnitude larger than the universe we saw 90 years ago, which is a good stat. When Edwin Hubble in 1926 realized that the nebulae, or some of the nebulae, were actually island universes, he called them, galaxies outside the Milky Way. People started racing around trying to measure the distances to these things, and it was clear that we had the universe wrong in terms of its size by 7 orders of magnitude, which is a big leap. There hadn't been a leap that big since the old Earth going around the sun business in the 15th century. The universe may be even bigger than that. This, of course, is Schrodinger's cat. Actually looks more like sort of Schrodinger's cat turning into Schrodinger's dog. I'm sure you're all aware of the quantum paradoxes. What happens to in a quantum dictated event? Do you end up with 2 of the objects existing simultaneously? The cat that walks out, is it the original cat? So on and so forth. And all this, together with some other fun stuff, has led to the idea of the many worlds hypothesis, which has become respectable in cosmology now. There are actually 4 levels of multiverse, which cosmologists talk about. One, this level 1, I like to think of as the kind of brute force multiverse, which is simply the universe we see is just a tiny part of a massively, almost infinitely inflated supercosmos. Same laws of physics everywhere. Infinite space. This means actually that if this holds, which eminent astronomers, cosmologists think it does, the maths of inflation seems to suggest that this is inevitable. That 10 to the 10 to, I think it was 10 to the 10 to the 120 light years away, there is an identical room to this with an identical me and an identical you all sitting here being given this talk with maybe one word differently. Level 2 is the Stanford sort of multiverse. Andrei Lindy, who's a Russian emigre cosmologist, very clever chap. He's come up with this idea of post-inflationary bubbles, little daughter universes splitting off from ours, maybe black holes. Level 3, the many worlds of quantum physics. Every time you have a quantum event, you have a whole new universe, one where Hitler won World War II, one where there was no World War II at all. And level 4, which I think is perhaps the most interesting one, which is whole different conceptual universes. Things like, I'm sure you've all heard of the Matrix universe, the idea that the world we see around us might be a simulation. People, maybe not 100 meters from here, are working with some very powerful computers. And the big question is it possible to simulate consciousness, for example, in a computer? If it is, then we shall do it fairly soon, probably. And we shall do it more than once. We shall do it millions of times, probably billions of times. And we simulate the weather when we run weather forecasts. If you go to NOAA or the UK Met Office, they run simulations of, 10 to the 9 simulations, 10 to the 15 simulations sometimes over days. And if it's possible to simulate even a small part of a universe, you don't need to do the whole thing. In a machine, including consciousness, and you do this trillions of times over, the chances are that we are all living in one of these simulations, so say some people, which is weird and disturbing. When faced with arguments like this, some people click their head in the sand. There was a famous lecture given by Carl Sagan once, and he was talking about cosmology and weird things, and a lady put her hand up at the end of the talk and said, but it's just the Earth. You're completely wrong, Dr. Sagan. The Earth doesn't float around in space. It sits on the back of a turtle. And he said, well, what does a turtle sit on then? Well, she said, it's turtles all the way down. And she may have been quoting somebody else. I think it's all very exciting. 1900, Lord Kelvin, inventor of the Kelvin temperature scale. There is nothing new to be discovered in physics now. All that remains is more and more precise measurement. Meanwhile, in a patent library in Switzerland, a young man who's rather clever was beavering away and coming up with some ideas which would blow that out of the water. We don't want to retreat into theology. I think there's theism. I think there's nothing wrong with deism, the idea that there might be something fishy, something about the whole setup. But traditional response to the great mysteries is to invoke this chap, to which the answer is always, well, why not believe in this chap as well? Thank you all very much.
There we are. Now we actually have sound plugged in. So my one question was, what's the 11th question? Were there any ones that were cut from the book that you wanted to include in a like a bonus director's cut, or
no. The 11th question comes in the next book, which is the next 10 questions Science Can't Answer Yet, which I am I'm working on now. I'm not going to tell you.
Right, I guess that wraps up our questions then. So thank you very much. It was a great talk.
Thank you all very much.